Astronomers have captured some of the most detailed images ever seen of the galaxies in deep space.
Has always found something they didn't expect, something new.
Images of the universe like we have never seen before.
In the earliest days of astronomy, researchers believed we were alone in the universe. But soon after, they discovered we reside within a galaxy called the Milky Way, filled with stars, the sun, and moons. With advancements in telescope technology, scientists observed that the Milky Way is just one of billions of galaxies, the closest of which is Andromeda. However, deploying the cutting-edge James Webb telescope has fundamentally improved our understanding of the origins of our galaxy, but recently, James Webb has been receiving abnormal signals from Andromeda. What are the shocking signals received by James Webb, and how will they reshape our knowledge of space? Join us as we discuss the mind-blowing revelations of the most advanced telescope ever built, Andromeda Galaxy and the Milky Way. While many pictures show the Earth as a spherical ball standing alone in the universe, this is deceiving. Our planet is part of a large cluster of space objects called a galaxy. That's not all. The universe has well over 100 billion galaxies, but the Earth lies within a cluster known as the Milky Way. The Milky Way contains billions of stars, other planets, gas, and dust. While Andromeda is another galaxy, it runs close to our Milky Way. Andromeda has been the focus of scientific inquiries for decades because it offers a comparative model for studying galactic structure and evolution. Astrologers have also found that observing Andromeda enhances our understanding of the dynamics and characteristics of spiral galaxies, including our own. But there is another shocking reason scientists are interested in the Milky Way and Andromeda galaxies. Research suggests that the Milky Way and Andromeda will collide in the future. However, such findings were only possible with the development of the Space Telescope. It is also important to mention that the collision between our Milky Way galaxy and Andromeda will take at least 4 billion years, so you need not worry much. Scientists suggest a new galaxy called Andromeda will form after the two galaxies collide. Andromeda will dramatically alter the structure and dynamics of both galaxies. There is something more interesting. Life on Earth will likely be long extinct by then, so you need not worry about your great-grandchildren. But why do scientists keep studying these events? To explain this, we need to take a walk down memory lane. A little more than 100 years ago, people generally believed that the Milky Way was a faint white strip that stretched across the night sky. People also had different beliefs about the Milky Way, some even thinking it was the center of everything, where the sky and the Earth met. Then, in the early 1600s, an Italian astronomer named Galileo Galilei changed our whole understanding of the Milky Way. Using a new telescope he built, Galileo made terrific discoveries that challenged the common beliefs of the time, which were based on the ideas of Aristotle. The things he observed through his telescope were a giant leap in astronomical studies. Still, before we reveal them, we must discuss one of the earliest attempts to explain the Milky Way galaxy. After Galileo's observations, English astrologer Thomas Wright published a groundbreaking idea in his book, An Original Theory or New Hypothesis of the Universe. Wright explained that the Milky Way wasn't just a jumble of stars scattered around space, but a giant, flat disk. He even believed our solar system was a tiny part of this large structure. While Wright's theory was a good attempt at understanding the Milky Way, it was limited by the telescopes of his time, and many astronomers held on to their erroneous belief that the Milky Way was the only galaxy out there. But by the 1800s, astronomy was making huge strides, and by the 1900s, our view of the universe changed dramatically. Deploying his new telescope, Galileo observed that the Milky Way was not just a blurry band of light. Instead, he discovered that what appeared to be a cloudy band of light to the naked eye comprised many individual stars. This significant revelation challenged the prevailing astrological knowledge at the time. That's not all. Galileo also used his telescope to study the moon. He observed mountains, craters, and valleys on the lunar surface, challenging the notion that the moon was plain and unchanging. In addition, he noticed that Venus has different phases, just like our moon does. This wouldn't be possible if Venus circled Earth, like most people thought back then. But it makes perfect sense if Venus travels around the Sun. So, Galileo's observations provided strong evidence that Venus goes around the Sun, not Earth. And there is another giant galaxy called Andromeda out there. Scientists think there might even be 100 billion galaxies in the observable universe. Believe it or not, we can't count all the stars. But thanks to Galileo's discoveries, we learned that our Milky Way is not the only galaxy in the universe. In the 1920s, American astronomer Edwin Hubble made a groundbreaking discovery using the Giant Hooker telescope at Mount Wilson Observatory. Hubble looked at faint, cloudy objects far beyond our Milky Way galaxy. By carefully studying these objects, he proved they weren't part of the Milky Way, but were entire galaxies, each containing billions of stars. One of our closest galactic neighbors, he observed, was the Andromeda galaxy, also known as M31. Some of the earliest known records came from the 10th century when a Persian astronomer named Abd al-Rahman al-Sufi described it as a small cloud in his star charts. It was nicknamed the Little Cloud. The fantastic thing is that al-Sufi identified this distant object without any telescopes, just his sharp eyes and careful observations. The development of modern powerful telescopes only increased scientific curiosity about our galaxy and space. One of the most studied galaxies today is Andromeda. Advances in telescope technology and discoveries about Andromeda. Andromeda Galaxy is remarkable because it's one of the few galaxies you can spot with your naked eye. No advanced telescopes are needed. You can spot it as a faint patch of light as long as you know where to look in the night sky. It might not be super detailed, but you can tell it's something different from the usual stars. The first detailed scientific observation of Andromeda was in 1612. German astronomer Simon Marius made a more detailed observation of Andromeda using his rudimentary telescopes, which paved the way for future astronomers to study this giant galaxy. Then, in 1764, a famous French astronomer named Charles Messier included Andromeda in his famous Messier catalogue, calling it M31. He mistakenly attributed the discovery to Simon Marius, not realizing al-Sufi had seen it centuries earlier. Even though Messier wasn't the first, he is credited for bringing Andromeda on the map for global astronomers. Astronomers spent nearly a century after Messier's catalogue trying to unlock the secrets of this mysterious neighbor galaxy, building on each other's discoveries. A breakthrough came in 1864 thanks to an English astronomer named William Huggins. During his career, William Huggins made remarkable discoveries using various telescopes. However, the one that stands out most is an 8-inch refractor telescope. This powerful tool was built by the famous telescope maker Thomas Cook. With this 8-inch telescope, Huggins made groundbreaking observations. He studied the spectral lines. This helped him crack the code on what these objects were made of and how they moved through space. It was a good development in our understanding of the universe, but the best was yet to come, as you would soon find out. While it is hard to imagine, astronomers found that Andromeda's mass is a staggering one to 2 trillion times that of our Sun. Scientists also estimate Andromeda to be around 10 billion years old, making it an ancient citizen of space. Astrologers debated over the years on how it came to be. One exciting idea is that several smaller ancient galaxies merged to form Andromeda. Over billions of years, gravity probably pulled these smaller galactic building blocks together to form the majestic Andromeda we see today. These galactic mergers are common in the universe, shaping how galaxies grow and take shape. But they happen so slowly that it's like watching paint dry. You wouldn't notice it happening unless you could observe for a long time, like billions of years. Astronomers also suggest that Andromeda was heavier than our Milky Way galaxy, but this has been debunked with the help of modern, powerful telescopes such as the James Webb. It's an understandable mistake. The James Webb Space Telescope. We live on our Milky Way, and Andromeda appears large from Earth. It's easy to think it is larger, but that's not entirely true. Before we continue, it is essential to discuss the pinnacle of space observation technology today, the James Webb Telescope. The James Webb Space Telescope is an advanced eye in space that peers at the universe using infrared light. This remarkable sight allows it to see things too far away, old or faint, for other famous space telescopes such as the Hubble. Because of this, JGWST is helping the world understand many mysterious things in space, like the distance of stars, the birth of entire galaxies, and even the atmospheres of planets outside our solar system that might support life. James Webb was launched in 2021 and traveled to a special spot in space about 1.5 million kilometers away from Earth. It reached its destination in January 2022, and in July of that same year, it shared its first incredible image with the world. That's not all. The James Webb Space Telescope got its name from a past NASA administrator. He was the head of NASA between 1949 and 1952. Unlike our eyes, Webb doesn't see the world in visible light. Instead, it uses invisible infrared light, perfect for spotting faint, distant objects. This extraordinary vision allows Webb to peer deeper into space and further back in time than ever before. This incredible vision comes from its massive mirror. Made up of 18 precisely shaped hexagonal pieces coated in gold, the mirror stretches to an impressive 6.5 meters in diameter. This is much larger than the mirror of the Hubble Space Telescope, allowing Webb to collect much more light like a giant bucket catching rain. With all that extra light, Webb can see fainter objects and capture sharper images. But there is a little problem with this multi-million-dollar piece of modern engineering. Webb's infrared vision needs to be incredibly cold to function correctly. It must be much colder than even the harshest winter on Earth, reaching temperatures below -223 degrees Celsius. If Webb weren't this cold, it would start glowing in the infrared light it's trying to observe, making it impossible to see the objects it is looking for. Webb relies on a special 5-layered sun shield that acts like a giant umbrella, blocking heat from the sun, Earth, and even the moon to keep it cold. Thanks to its robust technology, the James Webb Space Telescope is bringing in a new era of discovery. With its sharp vision and deep reach, Webb is helping us answer fundamental questions about the universe. Some of its recent findings are mind-blowing. For instance, could you believe James Webb has been making and breaking records? James Webb Space Telescope keeps breaking its records. It recently spotted the farthest galaxy ever seen, called Jade's GS Z14-0. This incredible discovery shows us the galaxy as it was just 290 million years after the Big Bang. Imagine that the universe is 13.8 billion years old, and we see this galaxy when Earth was just a toddler, only 2% of its current age. This remarkable feat was achieved by Webb's giant mirror and powerful infrared instruments. Webb's previous record was a galaxy 325 million years after the Big Bang, but Jade's GS Z14-0 beats that by 35 million years. But scientists believe the light comes from many young stars. Astronomers Stefano Carniani and Kevin Heinlein from Italy and Arizona are shocked at the revelation. How could such a bright, giant galaxy form in only 300 million years? That's a question Webb is helping us investigate. What else could advanced telescopes like James Webb help us resolve? Andromeda Galaxy through the scope of modern telescopes. Andromeda's weight and size are some of the biggest mysteries advanced telescopes have resolved. Although Andromeda's weight was initially controversial, one thing astronomers agree on is its impressive size. It stretches much farther than our Milky Way, boasting a diameter of around 220,000 light-years. That dwarfs our Milky Way's diameter, estimated to be between 100,000 and 175,000 light-years. This vast size makes Andromeda a true giant in space, taking up a considerable chunk of space. One interesting thing to note here is that it is not the size of a galaxy that determines its weight. Instead, the settings of the stars, gas, dust, and even invisible dark matter determine it. Andromeda also has an active galactic nucleus, or AGN for short. These AGNs get power from a monster black hole at the core of the galaxy. What astrologers saw when they used James Webb to peer into the heart of Andromeda's active galactic nucleus, AGN, is fascinating. The dimmer of these two areas is suitable in the galactic center, where a supermassive black hole sits. This black hole is estimated to weigh a staggering 110 to 230 million times the mass of our Sun. Supermassive black holes like this are thought to be expected at the centers of galaxies, including our own Milky Way. They play a significant role in the behavior of galaxies. When gas and stars get too close to a supermassive black hole, they get sucked in and form a swirling disk around it. The gravity around the black holes is powerful, pulling on everything around it, including stars. These stars zoom around the black hole, not in perfect circles, but in oval-shaped paths, like planets around the Sun. Instead of years, these orbits take millions or even billions of years to complete. Scientists predict a mind-blowing event in the distant future: potential collision and merger with the Milky Way. Milky Way galaxy and the Andromeda galaxy are slowly moving towards each other and will eventually merge into a giant new galaxy, which will fling some gas, dust, and stars between the galaxies. It might be messy in space, but there won't be any explosions or direct collisions between our solar system and anything else. This is what will happen. As Milky Way and Andromeda inch closer, stars, gas clouds, and dust clouds from both galaxies will mix. This grand mixing can spark the birth of new star clusters and never-before-seen structures within the merged mega-galaxy. We mentioned earlier that the Milky Way and Andromeda have supermassive black holes. As the galaxies collide, these black holes will eventually merge, forming an even more monstrous black hole at the heart of the combined galaxy. These regions will become giant stellar nurseries, breeding new generations of stars. The impacts of all these on Earth will leave you speechless. These significant changes in space could mess with our biosphere in several ways, although thankfully, as noted earlier, humanity will be long gone. Thank you for staying with us. Do you believe in the revolutionary power of space technologies like James Webb? Let's have your opinions in the comments section. If you enjoyed the video, like, share, and subscribe to our channel. Also, click the next video shown on your screen, and you will enjoy it.